So, good morning everyone. In this video, we will be talking about aggregation. So, we will be looking at aggregation and composition, what they are, okay, and we will also compare them. Okay. So, an aggregation is a strong form of association in which an aggregated object is made of constituent parts. Okay. So, basically, the constituents are the parts of aggregate. In this case, in this example, okay, so there can be a lawnmower, which can be an aggregate, okay, and there are several parts in it, okay. So for example, like there is a blade, okay, and then there can be an engine, okay, and a wheel, can be several wheels, okay, so based on the design, okay. So the constituents are the parts of this aggregate, so these are all parts of aggregate. Aggregation is actually shown in UML, represented like this one, so this hollow diamond, okay. So conceptually, the aggregate is semantically an extended object that is treated as a unit in many operations, although physically it is made of several lesser objects. Okay, say for example, in this case, like the lawnmower is made of this blade, engine, and wheel, but generally, like you will be talking only in terms of lawnmower. Okay, so you will not be talking in terms of blade or engine or wheel, okay, or some other parts. Okay, so the deck or whatever it is. Okay, the model is not complete in this sense. Okay, that's about aggregation. We define an aggregation as relating an assembly class to one constituent part class. Okay, so basically, like an aggregation in this one. Okay, so let's go by the earlier example. In this one, the aggregation is the lawnmower, okay, and the blade. So this is one aggregation relation actually between the lawnmower and the blade. Okay, so an assembly with many kinds of constituent parts corresponds to many aggregations. So going by the same example, say for example, this is an assembly class, okay, so which is like lawnmower, which is constituting several of these blade, engine, and wheel. Okay, so it can constitute, okay, so constitute parts corresponding to many aggregations. So in this case, like there are, in the previous example, we are seeing three different aggregations here. Aggregation 1 between lawnmower and blade, and aggregation 2 between lawnmower and engine, and then like aggregation 3 which is between lawnmower and wheel. Okay, so that's what that concept means. We define each individual pairing as an aggregation. That's what I have just thought. Okay, so that we can specify the multiplicity of each constituent part with the assembly. Okay, so more or less like this definition emphasizes that aggregation is a special form of binary association. So that means like these aggregations are special form of binary associations. You can also specify the multiplicity. Okay, a lawnmower can contain one blade. Okay, and then like say a lawnmower constitutes one engine, and then like it can constitute several wheels. Okay, so that example. So it is many to many relation. Okay, so this is one to many relation, one to many aggregation, more or less. Aggregation is transitive. Okay, so if A is part of B and B is part of C, by transitive, what it states is A is part of C. Okay, aggregation is transitive. Remember this one. Again, aggregation is also antisymmetric. So if A is part of B, B cannot be part of A, isn't it? So these are the two very important features of aggregation. So it is transitive and it is antisymmetric. So if we try to see like aggregation and association, aggregation is special form of association. Okay, it's not an independent concept. Okay, so that's what I even the example also like I have been telling. Aggregation basically adds like these semantic connotations, additional meanings for it. Okay, if two objects are tightly bound by a part-whole relationship, it is an aggregation. Okay, if the two objects are usually considered as independent, even though they may often be linked, it is an association. Okay, the same thing. So we have seen several association examples. We also have seen an aggregation example. Okay, in this one. But the decision to use aggregation is a matter of judgment and can be arbitrary. Okay, so it always depends on the context. It always depends on the problem. There are no hard line rules to basically specify like what is an aggregation and what is an association. Okay, so this needs modeling expertise. Okay, so and people will understand, and also like domain expertise. Okay, so people from the domain and then like modeling expertise will actually can put a proper aggregation and association. Okay, that's about aggregation. Then let us look at composition. UML actually has two forms of this path hole relationships. Okay, um, a general form is called like aggregation. Okay, and there is also a more restrictive form which is called like composition. Let's discuss composition. Composition is a form of aggregation with two additional constants. So it's also an aggregation form. Okay, but then like two additional constants. The first constraint is a constituent part can belong to at most one assembly. Okay, so in the earlier example, we have seen like there is a blade. Okay, there is, say for example, that lawnmower. This blade can be fit into that lawnmower, or like there can be several other models of lawnmowers. Okay, so and then like this blade can actually fit into several of those things. But whereas a okay, so in terms of composition is concerned, a constituent part can belong to at most one assembly. Of course, probably like even the blade is not a right example there, okay, because like it also at a particular instance like it fits to one assembly. Okay. So remember that one, a constituent part can belong to at most one assembly, so then it is a composition. Okay, once a constituent part has been assigned to an assembly, it has a coincident lifetime with the assembly, and this actually makes the blade to be as an aggregation. So even if that lawnmower is destroyed, like you take the blade and fit it somewhere else. Okay, it is not a complete composition relation there. Okay, thus composition actually implies like ownership of the parts by the whole. Okay, this can be actually very convenient for programming. Okay, especially composition. So deletion of an assembly object. Okay, so the assembly object is the one which is actually constituting all these things. Deletion of an assembly object triggers the deletion of all the constituent objects. So if you have a composition relation. Okay, hope that is clear. So let us look at an example, okay, of this sort of composition. Okay, so composition notation is again this diamond, but then like this is a solid diamond. Okay, next to this sort of assembly class. So for example, like here, see this one, a company is constituting. So basically, this is an assembly class, okay, which has several divisions. So a company is composed of several divisions. Okay, and a division is composed of several departments. Okay, that's how like the multiplicity here is one to many in both the cases. Okay, so now hopefully like the composition is clear. So a company is composed of several divisions, and the divisions are composed of several departments. So if a company is destroyed, so everything is gone, all the divisions and departments are gone. If a certain division is being terminated, so all its departments are also closed. Okay, so that is like more or less like so very strong way of saying. Okay, so the composition is, but look at the interesting thing. Okay, there are also persons who actually work for the company, and here is a very strong, see this one, this is not a composition anymore, this is only an association. A person works for the company. Why it is? And company and the person are objects of equal stature. Okay, even removing a company will not remove a person. Okay, so basically like he can work for a different company. Okay, so that's the basic idea for the association. See, with whatever the examples I have been given, okay, so in a different scenario, if for a different modeling where you may want like exactly like that one. Okay, so everything is free, so there are no hard rules. Okay, what is composition, what is aggregation, and then like what is association. Okay, So whatever the things like which I have discussed, that they are generic rules, okay, so which are mostly helpful for you to design a good model. Okay, now let us try to compare this aggregation and composition, okay, because like they are approximately similar path-hole relationships from the UML. Okay. Okay, let's try to put all the things and summarize these two. Remember this one, a path can be shared by several holes. That's what I have been telling. Okay, so even the blade from this lawnmower can be shared by several of them. Okay, so similarly, like look at this example here, there is a category. There can be several documents within a category. And a category is more or less like an aggregation of several of these documents. Okay, and these parts can be shared by several holes. Okay, so this document can be in several categories. Okay, multiple categories. But whereas if you look at the composition is concerned, okay, so this is composition, so this is wrong figure here. So I will update the slides. Okay. So whereas composition is concerned, part is always okay. So a part of the single whole. Okay. So for example, there can be multiple frames within a single window. Okay. So that's a composition relation. Okay. So again, what I'm saying is like this diamond is not a hollow diamond, but then like it is a solid diamond. Okay, so I will update the slides. Parts can live independently. Okay, so this is what I have been telling. Okay, so parts can live independently. So that means like the hole's cardinality can be 0 to star. Okay, so if, for example, like a document can also live independently. Okay. Whereas if you come to the composition is concerned, parts exist only as part of the whole. When the whole is destroyed, we already discussed, okay, they are also destroyed. So the parts are completely destroyed. Destroying a window will destroy all the frames. Okay. So again, if you think in terms of aggregation, whole is not solely responsible for the object. Okay, so that's for the aggregation. Whereas composition is concerned, whole is responsible and should create and destroy all these objects, okay, of the parts. Okay. So this is basically the difference between aggregation and composition. Okay. So again, this is from chapter 4 of that object-oriented modeling and design with UML book. Okay. Thank you very much for your attention.